Comparing standard and factored forms of quadratics. So, first off, which of these two would be considered the standard form?
The right.
The left. The left is the one that's considered standard, okay? This is standard. This is standard form, which means the other one must be our factored form. How do we go from standard to factored form? We factor. Yeah. And how do we go from factored form to standard form? We expand. Okay, good. So at least you guys have that understanding. So what we're going to do is we're going to compare these two, and then we're going to relate them to a graph. Okay? The very first one I'm going to expand very quickly. It's technically in our standard form right now. Oh, sorry, I lied. It's in our factored form right now. And we're going to relate it to the above standard form. So when we FOIL, we multiply the first terms by each other, we'll end up with 400. We multiply the outside terms, we end up with positive 40x. Inside terms is negative 10x. And last terms is negative x squared. Collect our two like terms. And I'm going to rearrange it to put the variable with the highest exponent first. So, what will the very first exponent be?
Negative x squared.
That's right, negative x squared plus 30x. I'm going to try to combine those two in one step. Okay? And then plus 400. If you guys notice, that's identical to what's up here. Let's do the same thing. In this question here, we're going to factor it. Now, if you notice, we have a negative value, and we're not used to using a negative value when we're factoring. I always told you guys to try to make it positive. So how can I make this first variable positive?
Divide positive.
Switch it to positive and switch all the other sides to the opposite.
Okay, so what I would do is a common factor, I can divide by -1 as a common factor. The -1 would come to the outside, and then all of the terms inside the brackets, okay, would switch operations. Minus 30x, minus 400. Okay? Now, because this a value is technically +1, I really just got to find two numbers. I got to multiply to -400 and add to -30. Anyone know quickly off the top of their head what those values will be?
400.
What is it?
40.
-40 and +10 will work. Remember, they'll both add to that and they'll multiply to this up here, which means I can quickly go to the factored form. I still keep that -1 on the outside. We have x as the first term in each, because those are the only factors of the first, x squared. And we have -40 and +10. But is this identical to this one here? There's a little bit of a difference. What's the difference here? Mitchell?
The x in the first background, that one's negative and it's positive.
Yeah. So these two are technically the same, right? Positive xm, +10. They've just rearranged it. We just have the x first and the +10. No real difference there. Technically, you just rearrange it. But in the other one, this is a negative x value. This is a positive x value. This is a +40. This is a -40. What do they do? How come it's different? Are we wrong?
There's a -1 on the outside.
That's right. So this could have been represented by factoring out the negative and turning this positive and this negative, or we could FOIL this in. Now that's just a side note, okay? Both are technically the same thing, and when we do our X Intercepts and stuff, we're going to find the same thing. So what we're going to do from here now is we're going to use these forms and see how they can help us when we're graphing. Okay? Now, in factored form, this is technically equal to, I think it's a revenue formula, so they called it R at X. Same thing as F at X. We're going to graph this. So let's pause this and get a graph. So we brought up our graph here, and I need to actually graph this formula, or these two quadratics. So we're going to figure out how to go about doing this. Okay? There's benefits to the standard form and the factored form. The standard form will give us one important point on a graph very quickly. Anyone know what it is? This last term here gives us something very fast. The y what?
Intercept.
Intercept. Standard form will tell us our y-intercept very quickly. Okay? This is our y-intercept. In other words, the c in the standard form is the y-intercept. Now I'm just going to change the y values to go up by hundreds. Okay? And it's fine if our scale is a little different. It's not technically wrong. Okay? So what is our y-intercept?
400?
400. Positive 400. What else can the standard form tell us very quickly? It won't tell us x-intercepts. It will tell us something about an opening, though.
It's basic. Yeah.
That's right. Why do we know that? Because our a value is negative. So we know we're going to have some quadratic that is going to face this way. Okay? We just don't know our important points like the vertex or the x-intercepts. We've got a y-intercept, which is great. Standard form helped us with that. Now, factored form is going to help us with x-intercepts. Okay? Now, we'll quickly talk about why the y-intercept is found quickly in standard form. If x is 0, okay, and that's when we're on the y-axis, if x is 0, this becomes 0, this becomes 0, and we're left with 400. Okay, that helps us solve for the y-intercept. For the x-intercept, we have to set y equal to 0. In other words, the number on the outside or the other side becomes 0. So we're going to have 0 is equal to negative 1, x minus 40, and x plus 10. Now, I'm going to move that negative 1 to the other side, so I divide both sides by negative 1. Is that going to change the left side of the equation? What's 0 divided by negative 1? Negative 0 or 0. It really doesn't matter if it's positive or negative 2. The 1's cancel out, and we're just left with x minus 40, okay, and x plus 10. Now, these are multiplied by each other, okay? We need to create 0. There's only one number we can multiply by to get a 0. 0. So in other words, one of these brackets must equal 0. We just don't know which one it is. So we're going to test for both of them. We split the equation. And we set both of them equal to 0. So I have 0 is equal to x minus 40. And I have 0 is equal to x plus 10. And we're going to solve for x in both of them. When I move 40 to the other side, what will it become? Positive 40. And when I move 10 to the other side, what will it become? Negative 10. So negative 10 and positive 40 are our two x-intercepts. So, these are supposed to go by 10s. Imagine these are going by 10s also. Quickly fix that. Okay, so we have positive 40, which is here, and we have negative 10, which is here. Okay, that's great. I've got y-intercepts and x-intercepts. I just don't know what part. The vertex. How can I find the vertex with x-intercepts? Yes, we're going to find the midpoint between the two x-intercepts. It's known as the axis of symmetry. Okay, so the axis of symmetry, AOS, is equal to, and I'm going to rearrange it. They usually call it R and S just because in factored form we call the x-intercepts R and S. I'm going to call them x1 and x2 because really they're referring to the two x-intercepts. Okay? We're going to add the two values together and divide by 2. Well, what are our two x-intercepts?
40 and negative 10.
40 and negative 10. So we have 40 plus negative 10 or minus 10. Divide 2. 30 divided 2 is, amazing, 15. So, we know our axis of symmetry is at the value of positive 15. So it comes through here. We know the vertex is going to be right there. How high does the vertex go?
150.
Wait, how do you get the vertex if it was 15?
That was the x value of the vertex. So we know the x value, or the axis of symmetry is 15. How high does the vertex go?
You just plug in the x value.
Yeah, we got to still figure that out. So we're going to plug in this 15 value, and we can plug it either into the standard or the factored form. Okay, you guys want to plug it in standard? Okay, if you think that's easier.
Is that the one with like distributing?
F at x is equal to negative. We're going to replace the x value with 15. So just look back at the top again, you're going to remember the equation. It was negative x squared plus 30x. X is 15. And then plus 400. We'll need a calculator for this one probably.
225.
Negative 225.
Mental math.
Well, sir, if it's negative x squared, would x be considered negative, or would it be like that with the bracket?
It's going to be like this.
Sir.
Hold on. 225. We multiply this value, what are we going to get?
30 or 50.
450 and plus 400. Okay. We put these together, that's 850 minus 225.
675.
625.
625. 625. Good. So, 625 is roughly there, which means we've now found every point of our graph that is important for us. We have our y-intercept, we have our vertex, and we have our two x-intercepts. So, standard and factor form can help us graph everything we need to graph.